In this video, we're going to look at some examples of confidence intervals for means. And remember that a confidence interval is the process of estimation, using data from a sample, a statistic, to make a statement about where we think the population parameter, the truth, actually is. And I say is because the population parameter is a fixed, potentially knowable thing. You could take a census and go out and get everybody in the population and find out what that parameter is. But usually we take a sample instead. It's more efficient, it's cheaper, and it's easier. But we're going to look at some examples of confidence intervals for means. Now, when we write these up, we use the very special language, we are 95% confident. And that means that's a signal that we've done the process of estimation. And so again, we see we're talking about the population parameter. In this case, we're talking about the mean or the mu. And we say that it lies, it is, and then we give the interval that we have. So we take our mean and we add a fudge factor to each side. So we go plus and minus. Some multiplier. We're using the number 2 for now, but we're going to see that it's actually a little bit different than that. 2 times the standard error of the mean. And the standard error of the mean, if you remember, is two things. It is how spread out is that thing, the sigma or the spread in the population, and what is our sample size, the square root of the sample size. In a table, you might see a confidence interval tabulated like this, the mean, and then they give you that standard error. And we know that you could take that and do this and make your confidence interval. Now, I want to show you a few examples of how this is used graphically. These are data on the number of work loss days during the preceding 12 months. Now, think for a second, how would you operationalize or define that work loss day? Well, this comes from a very large survey, the National Health Interview Survey. And to them, a work loss day is defined as this. In the past 12 months, how many days did you miss work because of illness or injury? Do not include maternity leave. And it's only asked among people who had worked in the past week. So you want to always look closely about the details of the question and the sample and so on. So let's take a look at the statistic. In this study, they found a mean of about 4. So the average person misses 4 days of work during a year because of illness or injury. Now, you could look at that number and say, yeah, but Tybor, that's just a sample. What does that say about the population at large? We don't know. Maybe this is a good sample, a good random sample, but the truth can't be exactly 4. There's no way. And that's what this confidence interval allows us to do. So around that mean, they put this confidence interval. And you can see that the CI goes from something like, I don't know, maybe 3.8 to 4.2. 3.8 to 4.2. We are 95% confident that the true number of days missed due to illness or injury is between 3.8 and 4.2. What do you think about that interval? How does it make you feel? Well, it's pretty narrow. It's pretty tight. Who cares about these data? Why do we collect these? Well, if you're an employer, you might need to prepare for how many days of backup do I need? How many days of sick leave do I need to pay? Between 3.8 and 4.2, if the truth is 3.8, are you going to behave very differently than if it's 4.2? Not really, right? We get a pretty good sense of what the truth is. Now, I want you to look for a second. I want you to look at this group of people right here, age 18 to 24. Now, notice that they miss fewer days of work because of illness or injury. But also notice that the confidence interval is a little bit wider. We use the term precision. The confidence interval is less precise. So if the confidence interval comes from the SEM, and the SEM is the standard deviation divided by the square root of the sample size. Who's recording this today? Is this Antonia or Monica?
This is Monica.
Oh, hi, Monica. Are you paying attention?
I am.
Okay. Why do you think this confidence interval for these people might be wider than the total based on here?
I'm not much of a math person.
Have you been listening to anything where statistics is not about math? I'll tell you the answer. So these people here, the younger people, they're a subset of the total. And so the sample size is smaller, right? The sample size is smaller. So the SEM would be bigger and the confidence interval ends up being a little wider. So I think it's a cool example where you can actually see that the size of the sample drives the width of the confidence interval. These are pretty cool data. These are older, but see if you can find new updated information on that. Here's another cool example. These are data on the average number of bed days during the preceding 12 months. Wait, Howard, didn't we just do that? No, well, we talked about days lost at work due to illness and injury. This is a bed day. Now, a bed day, what do you think the definition of that is? It's not, so I'm recording this in 2020. So a bed day is not when you sit at home and watch Top Chef or Tiger King or Schitt's Creek. A bed day is defined as this: day spent overnight in a hospital or which you're kept in bed because of an illness or an injury. And so let's look at this number here. For young people, now defined as 18 to 44, we are 95% confident that the true number of bed days is somewhere around this confidence interval. Notice how tight that CI is. See how narrow that is? That tells you a little bit that this study must have a large sample size to be able to get into the truth that much. Now, take a look at the older people in this sample. Look at that confidence interval. It's very wide. We would say it doesn't have a lot of precision. The truth might be somewhere between 7 and 11. And now we start to think about how useful is that? In this sample, I got something like 9. My X bar is 9. But the truth, we're 95% confident the truth is somewhere between 7 and 11. That's pretty wide. You might decide to do different policies or to institute something different because 7 and 11 could be quite different. But let me ask you this. If the SEM is driven by the standard deviation and the sample size, why is this one so wide? Well, partly it's the sample size, right? This is a subset of the full population. But partly, I think, if you look at the numerator, the top of this equation, there's a lot of variability in old people of how much time they're in a hospital or how much time they're in bed. When I was a kid, my grandmother spent every single day in bed, 365.25 days per year in bed. I don't know anybody in this age group who spends that much time in bed. So because there's more variability in the population, it's harder to hone in or get a more precise estimate of what the truth is. That is the end of the examples of confidence intervals for means. Drop a like, subscribe to my YouTube channel.